Hi friends, today I am going to discuss about the topic Markov chains. Introduction. A Markov chain or a Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. The defining characteristic of a Markov chain is that no matter how the process arrived at its present state, the possible future states are fixed, and Markov chains arises in a statistical context and are widely employed in a health, economics, game theory, communication, genetics, and finance. The basic concept of a Markov chain. Markov chain is a stochastic process, but it differs from a general stochastic process in that a Markov chain must be memoryless. That is, the probability of a future actions are not dependent upon the steps that led up to the present state. This is called the Markov property. While the theory of a Markov chain is important precisely because so many everyday processes satisfy the Markov property. There are many common examples of stochastic properties that do not satisfy the Markov property. And in Markov chains, there are two different types. Those are discrete-time Markov chain and continuous-time Markov chain. Example for a discrete-time Markov chain. The one example to explain the discrete-time Markov chain is the price of an asset where the value is registered only at the end of the day. The value of a Markov chain in discrete time is called the state, and in this case the state corresponds to the closing price. A continuous time Markov chain changes at any time. And by taking the another example, a Markov chain can be stationary and therefore be independent of the initial state in the process. This phenomenon is called a steady state Markov chain, where the possibility for a different outcomes converges to a certain value. However, an infinite state Markov chain does not have to a steady state, but a steady state Markov chain must be time homogeneous. Now let us see the applications of a Markov chain. The first one is epidemiological model. The Markov chains are usually called as the epidemiological and in the chemistry literature compartmental models. The most famous is the SIR model for a infectious disease. The main idea is that individuals can be classified into three states, that is susceptible, that people that can get the disease, infected people that have the disease and are contagious and removed, and it is shown in the below graph. And the second one is chronic disease model. Chronic disease model do not usually have interaction between compartments. Think in diabetes, which is not contagious. The main idea is that everyone is healthy, then gets the disease and finally dies. The discrete time Markov chain with a stationary transition probabilities is often used to investigate treatments programs and healthcare protocols for chronic disease. We can use a discrete time Markov chain to describe such movement using the transition probabilities between the health states. Thank you.